Hello everyone, it's Michael again. So today we are going to do a walkthrough how to work with Amazon S3. In this lab, you are going to use Amazon Simple Storage Service, Amazon S3, to host a static website. You will also implement architectural best practices to protect and manage your data. After completing this lab, you should be able to create a static website by using Amazon S3. Apply a bucket policy on an S3 bucket to configure customized data protection. Upload object to an S3 bucket by using the AWS SDK for Python Boto 3. Configure the website that is hosted on the Amazon S3 to be accessible only from a specific IP address range and test the configuration. So here's the scenario. Sophia is eager to start building a website for the cafe. She has some Python development skill and she's learning more about how to develop solution on the cloud. Nikki is a secondary school student who also works at the cafe. She has some skill in graphic design and strong interest in learning about cloud computing. The cafe has a single location in a large city. It mostly gains new customers when someone walks by, notice the cafe, and decide to try it. The cafe has a reputation for high quality dessert and coffees, but their reputation is limited to people who have visited or who have heard about them for their customers. Sophia suggests to Frank and Martha, her parents and the owners of the cafe, that they should expand community awareness of what the cafe has to offer. The cafe doesn't have a web presence and it doesn't currently use any cloud computing services. However, that situation is about to change. In this lab, you will play the role of Sophia and take the first steps needed create a website for the cafe. It's time to get started. So when we start this lab, the following resources are already created for our AWS account. So here's a developer. We have AWS Cloud, AWS Cloud 9 IDE, EC2 instance used to author, edit Bodo 3, Python code, run AWS CLI commands. At the end of this lab, your architecture should look like the following example right here. We have the developer inside the AWS Cloud, inside AWS Cloud 9 IDE. We have EC2 instance used to author, edit Bodo 3, Python code, run AWS CLI commands. Then create bucket, apply bucket policies, and upload file using AWS SDK for Python. Here we have bucket policies, limits source of objects requests to the S3 bucket hosting cafe website. Here we have forbidden source IP, general internet, HTTP, allow source IP, cafe network. Here's the user. Okay. Okay, so a business request for the cafe. Create a static website. Sophia mentioned to Nikki that she would like to build a proof of concept website for Frank and Martha that will showcase the cafe's offering visually. It would also provide business details such as the location of the store, business hour, and telephone number. Nikki is eager to see how she will build the website and she agrees to create the graphic that she will use. For this first challenge, you will take on the role of Sophia and you will use the AWS command line interface, AWS CLI, and the SDK for Python to configure Amazon S3 so that it hosts basic websites for the cafe. Task 1 is connecting to the AWS Cloud 9 IDE and configure the environment. In this first task, we will configure the AWS Cloud 9 environment to support the development that you will work on during the rest of the lab. So connect to the AWS Cloud 9 IDE. So from the service menu, we go to search Cloud 9. and here it is. You should see an existing IDE that's named Cloud9 instance. Choose open the Cloud9 IDE load in the new web browser tab. So open it. Okay, just loading. Now what we are going to do is we're going to install the AWS SDK for Python in AWS Cloud9 Bash terminal located at the bottom of the IDE. Run the following command: sudo pip install boto 3. So let's run this command right here. Sudo pip install boto 3. Okay, it's downloaded. It's good. Notice that you might see a note that you aren't using the latest version of pip, but you can ignore this message. Next, we're going to download and extract files that you will need for this lab. So in the terminal, run the following command right here to extract the file that you need for this lab. Awesome. The code.zip file is downloaded to the AWS Cloud9 instance. The file is listed in the left navigation pane right here. Okay. Now run the following command to extract the file. It's extracted. Tips: you will use the file that you downloaded and extracted later in this lab. Verify the AWS CLI version 2. Verify the CLI versions by using this command right here, AWS / version. So we have version 2.15.13 Python. To confirm that the AWS CLI version 2 is installed, the output should look similar to the following right here. Good. Now task 2, we're going to create an S3 bucket by using the AWS CLI. In this task, you will create an S3 bucket to host your website. You will complete this task by using the AWS CLI. In the AWS Cloud9 Bash terminal, run the following command: replace bucket name with your bucket name. For the bucket name, use the following item separated by the dash: your initial in lowercase, today's date in the format, and the word S3 site. For example. Okay. Let's check my bucket name. Okay, this is try to reconnect. Reconnecting. Let's go back. Run the following command: replace bucket name with your bucket name. Let's see. For bucket name, use the following items separated by dash: your initial lowercase, today date in this format. Alright. So what we're going to do is replace this with the instruction: my initial mv dash today days. The year is 2024 dash month January 01. Date is 27 and separates by another dash with the word S3 site. Awesome. So the terminal should return this, right? Something like this. Awesome. So let's try that. Oh, terminal is connected. Try to reconnect. Unable to run. Use this feature to refresh. Let's refresh this. Okay. Try to run this command. Yep. This location. Name the bucket. Really good. Okay. Awesome. So here's the tips. Copy the bucket name. Copies the bucket name text file in AWS Cloud9 IDE on your computer so that you can easily copy it during the later step in this lab. The bucket name does not include the leading slash that was returned in the location name value pair. So what I'll do is copy our bucket name and then return it to somewhere else. Let's refresh this. So I put my bucket name here, put it here temporarily so you can use this later. Go back again. So use the AWS management console to confirm that the bucket was created and observe the current permission setting of the bucket. So in the AWS management console, choose service and select S3. Okay. Let me go open another page. Go to S3 in service. You should see that the bucket was created. Yes, the bucket is created. The access column for the bucket indicates that the bucket and object is not public. Choose the bucket name and then choose permission. Choose the bucket name and choose permission. Okay. Notice that block all public access is turned on. Choose edit and deselect block all public access. Okay. Save it. Enter confirm. It is confirmed. Then next, what we'll do after we deselect all the public access, select block public access. Oh, we're not finished yet. Let's go back. Okay. What we want to do is we want to select block public access to bucket and objects grant to Neo access control list ACL. This one right here. Also select block public access to buckets and objects granted to my access control list. They choose ACLs right here. Alright. Then select this block public and cross account access to buckets and objects to any public bucket or access point policies. Then choose save changes. Confirm. Okay. Cool. In the confirm, then we choose confirm. Notice that you will configure the bucket with the bucket policy later in this lab. Scroll further down and observe that the bucket currently doesn't have a bucket policy attached to it. Bucket policies. Nope, no bucket policies just yet. Go back. Task 3. Setting a bucket policies on the buckets by using the SDK for Python. Now that Sophia has created the bucket, she wants to set permissions on the bucket. She wants Frank, Martha, and Nikki to be able to access the first version of the website that she's building so that they can see the progress she's making. However, she doesn't want to expose the site to outside world yet. She will accomplish this objective by configuring a bucket policy on the bucket. This bucket policy will enforce a condition. Now create a policy document. So in the AWS Cloud 9 IDE, in the navigation pane, choose Cloud Instance Directory. All right. Choose the Cloud Instance Directory. Choose New File, and then choose File. Choose File, and then New File, and then choose File. Save. Alright, find new file. The name of the empty file should be this. Choose save. In this, you should have this code in here. Oh. Okay. Paste it in here and then save it under this name, website security policy. So save. It's a new name. We'll delete this. Save this. Oh, kind of save it. Interesting. Let me refresh this. It's not connecting. Okay. What I'll do is I want to go save. Okay, it's safe now. In the policy document, replace all the 3 bucket name entries with your actual bucket name. Very good. Let's see, 1, 2, 3 right here. So I will copy my bucket name. Put my real bucket name in here. replace bucket name with my actual bucket name. One more right here. Then dun dun dun. Okay. Good. Now I want to save it. Entries with your actual bucket name. Finally, replace IP address with the IP address that is being used to connect your computer to the internet. You can find your IP address by visiting this. So what is my IP address? I'll copy this one. That's my IP address. To the internet, so you can find your IP address by visiting this. Now looking for IP address. That's the only one IP address that we need to put on. I'll save it. Know that you won't be able to view the website if you use 000 as they allow AWS source help, because Amazon S3 is smart enough to recognize that means public access. And since you just set the bucket permission to block all public access, S3 will block your access. Therefore, ensure you use your specific IPv4 address. Click Save, which we already did. Analysis. This policy document consists of two statements. The first statement allows get object requests from your IP address. The second statement denies access to an object in the bucket that's named report.html unless a specific condition is met. The report.html file doesn't exist in the bucket yet. However, in the later lab, you will upload the report.html file to the bucket and configure pre-signed URL access to it. The later lab will explain the details. Apply the bucket policy to your bucket by using the SDK for Python. So in the navigation pane, expand Python-3 directory. And open permission.py file which contains starter code. Edit the files by replacing bucket name with the name of your bucket. Alrighty. There's only two bucket name, one bucket name here that we need to replace. Go back here, replace this with our actual bucket name. Very good. Then save changes. Finally, in the terminal, navigate to the Python 3 directory and run the following code. So run this code and change directory to Python 3, and then we're going to run this Python file permission.py. Done. Very good. If the command completed successfully, you should see the message done, which we did in the terminal output. Optional. Return the browser tab where the Amazon S3 console is open and observe that the bucket policies has been applied to the bucket. You might need to reload the console page. Okay. Let's go here. Refresh it. and we see the bucket here, the bucket policy. All right. Task 4: uploading objects to the bucket to create the website. Now that Sophia has configured permission on the bucket, she needs to upload the website objects to the bucket. Fortunately, Sophia created the website's code some time ago and is in the resource directory in the AWS Cloud 9 IDE. Nikki created the graphics for the website, and she excited to see that the website will look like Sophia is now ready to upload the files. To complete this task, she will use the AWS Cloud 9 terminal to issue a simple recursive file upload command and disable caching since the website is still being developed. We're going to run this command here and replace it with our actual bucket name. Run it. And then task 5: testing access to the website. Now that Sophia has uploaded the website files to the S3 bucket, she must test the site and verify that it loads when a user accesses it to a virtual secure endpoint. Load the website in a browser tab. Return to the browser tab with the Amazon S3 console. Okay, so load the website in the browser tab. So return to the browser tab with Amazon S3 console. Amazon S3 console right here. Go back. Choose the bucket name and then choose object. Okay. If the files you just uploaded do not display, choose the refresh icon to view them. Then choose index.html5. So just want to make sure, refresh it, choose the index.html file. Copy the object URL. It will be the following format. Copy it. Notice that in this lab scenario, the S2 bucket you created is intentionally not configured for static website hosting, a feature available in the bucket properties. Instead, you will access the website using the object URL of the index.html file. Verify that your website is displayed by pasting that full URL into your browser, ensuring you are on the same network, as it will block any other than IPv4 you specified earlier. So I'm going to paste the website link, and here it is, loading, looking nice, beautiful. Let's refresh it. Oh, zoom in. Nice. So this is the website. Awesome. Now try to access the same URL from a location outside of your network. Ways that you can test outside access: if you have a mobile phone with a cellular network connection, try loading the same URL in the browser on your mobile phone. Another way to test this is by running the following command in the AWS Cloud 9 bash terminal, where bucket name is actual to bucket name. Okay, let's try this. Go here, try to run this, see what happened. Error, access denied, error. So here is the analysis. Regardless of whether you load the page from another location or use the curl command from a Cloud9 instance, an attempt is made to retrieve the page that you specify. It should return an access denied error because your mobile device or the AWS Cloud9 instance, whichever one you choose to use, connects to the internet by using a different IP address than your computer. The essential point is that you should only be able to access the website if the device uses IPv4 address that's specified in the S2 bucket policy. In the cafe story, this IPv4 address is the cafe's network IP address. Test that the website is loading. So back in the browser tab where the website load correctly, choose login on the top right of the header. Okay, no API to call. An alert will display saying no API to call. This behavior is also expected at this point in the course analysis. In the next lab, you will begin to create an application programming interface API that the JavaScript code in this website will interact with. For now, however, that API doesn't exist yet. Task 6, analyzing the website code. So Nikki watched as Sophia configured the website. Now that the website is hosted and working, he asked Sophia to explain the code within the site. In the AWS Cloud9 IDE, choose resources and then go to website directory. Resources to website directory. And then open the index.html file. Website directory, open the index.html file right here, coding in HTML. Okay, notice that this HTML page reference a number of CSS files in the head sections right here. So it's reference CSS file, different CSS file right here for reset, main navigation, pastries, coffee, beans, and front. No, not front. That's the different for font. But here are the CSS file for our styling to HTML element section. So toward the end of the body section, the code reference a few JavaScript JS files. Some of these JavaScript files define the essential features of the site. One of these files is named config.js. Another one of them is named pastry.js. Say in toward the end of the body section right here, pastries, coffees, main.js, config.js, pastry.js. Open the config.js file. Okay, window.coffee config aside to API to know, cognito login to know. So it does contain this code right here. As you continue through the labs in this course at the appropriate time, for example, when you add Amazon API, Gateway, and Amazon Cognito to the website implementation, you will set values for these keys and overwrite the content of these files on S3 with the changes. Then the behavior of the website will adapt to the enhancements accordingly. Let's see it one more time. As you continue through the lab, discuss the appropriate time. For example, when you add Amazon API Gateway and Amazon Cognito to the website implementation, you will set values for these keys and overwrite the contents of this file on S3 with changes. Then the behavior of the website will adapt to the enhancement accordingly. Now open the pastries.js file. Pastry.js5 in the script folder. Notice that the logic defined in the load all items function, that if the API GW base URL str has a value of no, which it currently does as you saw in config.js, then this function will print the item contained in the file named all products.json. Right here. So there's a if conditional statement to check if this coffee config API right here is no. If it's no, then it's going to print out this. Observe the print item function details that are defined further down in the code. Observe the print item function details that are defined further down in the code. So print item. Let's see. So here our function print item right here. So for the function print items, we're going to put our parameters response, so to pass it in our response argument. We declare a variable HTML str assigned to an empty string, and for this variable HTML str, we go to increment this string right here, section class assigned to flex grid, and then we make a if conditional statement to check if the response properties products item array. Then we use this for loop to check starting at I int assigned to 0 assigned to empty object I int. If I int is less than this response dot product item array length, then we go increment I. Then we going to assign O to response product item array at the index of I int. Then we're going to increment HTML str with the string, the product ID, and this closing bracket. Another nested for loop. We're going to do similar things. Check the length of tags of tag str array. If this tag array at this current index is equal to on offer, then we're going to increment this string right here. If however is this whole cell, then we're going to add this string right here to our HTML str. And then within the outer for loop, what we're going to do is we're going to keep adding this element right here, the string, an element right here for each iteration. At the end, outside of the outer for loop, we add in this section right here and this string template for as our element and append it to. Then what we're going to do is at the end we will append all the string inside HTML str. Very good. Awesome. All right. Now open the all product.json file. After observe the print item. Yes, we already observed the print item. Now open the all product.json file. All products.json. This is the JSON file to store our products information. Notice that this JSON file contains information about all the products that display on the website. For now, this product information is stored in this file hosted on Amazon S3. However, in a later lab, you will migrate this product information into a database. Optionally, browse the other files that make up the website to get a sense of how the website code works. The files have been left obfuscated, so you can read them as you wish if you wish. However, you do not need to understand this application code in order to complete this course. Okay, so this is our JSON file. So this is another JSON file storing our offer, prices of each item, and so on. This means here another JSON file. A JSON file is store our information. It's basically here is a look like an array of objects. Each object is our item information. Okay, it's looking good. Let's go back. Updates from the cafe. Sophia is pleased that she now has a basic website that hosted on Amazon S3 because it's still a work in progress. She makes sure to configure that this site so it's only accessible from the cafe network. Frank and Martha are both pleased with the results so far. Sophia takes a minute to relax, but she's also already looking forward to the next task. She's planning to start developing the components that will make this site run dynamically by using REST API calls to a database backend. Awesome, so that is pretty much for this lab. Thank you so much for watching and have a good day.